Hi, I'm Paco Nathan from O'Reilly Media, and today it's a great pleasure to get to speak with Gary Brown, Director of AI Marketing at Intel. Welcome,
Nice to meet you. Great. Thanks for having me here.
Can you tell me a bit about your background and sort of the path coming into Intel?
Oh, that's an interesting question. I had an exciting career as a design engineer in the past. Graduated from a university and went to Japan to work as a semiconductor design engineer. It was a lot of fun, but I realized I needed some more advanced technology training. Came back to get a master's degree and found myself wanting to go work for some small companies. One of them was Dolby Laboratories, the audio company, where I fell in love with audio digital signal processing. And in digital signal processing, there's a lot of mathematics. My degree in school was in engineering mathematics. So I found in audio and then later in multimedia and video, there was a lot of interesting kinds of things people were doing and customers were doing. I'm a very social person, so I started working with customers. And then I got this bug to work in marketing, and the rest is history.
Oh, fantastic. and these kinds of applications, the audio and the video, into those kinds of use cases, it leads directly into AI.
Yeah, that does, because especially in video and visual technologies, there's always a need for some level of intelligence. Right. So there are tons of technologies with cameras, but all of these use cases, whether it's video cameras for consumer use or industrial use or retail use, they're always getting smarter. And so the movement of cameras to go from just image capturing or video encoding to having some intelligence, sending data to an analytics server in the data center to be able to have better security in an airport, or better security in a retail store, or medical imaging and medical analysis, that all lends itself to AI technology. And now what we're finding is there's this new era of moving that AI technology to the edge close to the camera sensors. So having cameras that within themselves can do processing, media analytics, tracking of people, or being able to do things for these kinds of industries, retail, or for medical imaging in a handheld device, but also in small appliances, and making these kinds of technologies available for small appliances, small devices. That comes with a lot of huge challenges, but there's also a lot of opportunity just because of the sheer amount of AI research going on.
Now, so in contrast to what we usually think of as like ginormous data centers and massively compact, addressing what business needs out in the field with these kinds of use cases, there were some announcements recently from Intel.
Yes, that's right. Just the other day here at the O'Reilly conference, we announced a set of vision accelerators. So what Intel is doing at the IoT group where I work, we're putting out software that can kind of help developers create AI algorithms and port them to our CPUs, which are very commonly used in data centers, in PCs, development platforms, and then move those AI algorithms easily into these very low power accelerators. Right. So we're taking these vision processors and FPGAs and other kinds of low power, cost efficient processors, and are able to accelerate the same algorithms that people are developing for CPUs. So what that means in these kinds of applications, let's just take a smart factory, for example. Many smart factories, I think in the next few years, are going to be upgraded to more visually intelligent factories that are able to, there are many applications even within a factory, where a factory worker, are they wearing a helmet? Are they wearing their safety equipment or not? And just to have latent cameras being able to detect when a factory person should be warned to wear their helmet because they're not wearing their helmet.
Are they accidentally standing
detecting
in the way or something?
Helmets and detecting people, you could easily do that. Yeah. But to be able to do it on site and not have to stream to the network means you're saving power, you're saving performance, you're creating small on-premise appliances that can quickly give you the answer, and with privacy. You don't have to send data into the network and back. And so these kinds of there's many applications in transportation, smart cities, being able to keep airports safe. Cameras are going to have to maintain their video and do very fast, low latency analytics on site. And then through the cloud, you can take the metadata and then be able to do intelligent kinds of decision making based on the metadata rather than based on the video streaming itself.
So at a higher level, more aggregated.
That's right, that's right. So the hardware behind all of this comes from Intel, and what we announced was the ability to be able to put these accelerators out in a way that scales really easily because of a big partner ecosystem that we're building. People that can take our chips and build boards, people that can take the boards and build the boxes, And then companies like Microsoft and Amazon, who announced their cloud services running on these kinds of platforms, as well as Honeywell doing security and other kinds of technology companies doing retail. Making the experience for consumers much better based on visual intelligence in the retail store. For example, you go to find a product on the shelf and you pick it up and the price is too high and you put it back. But using the cameras in the store, they can tell how many times people have actually picked the product off the shelf and put it back, things like that.
A very different definition.
That's
of a marketing
right, that's
funnel.
right. And even in medical applications where you're trying to identify either cancerous tumor on a skin sample, using the cameras to be able to quickly give you a sense of, is it probably something you should be warned about or not? We have examples of customers that are detecting disease in eye scans just really quickly and being able to put a lot of images through to be able to have very accurate detection of disease. So all of this has to be done in very low power to be able to deploy it to many hospitals and to many doctors' offices. It's really exciting.
The scale is, it's almost overwhelming to look at the addressable scale out there, the need. Can you give me some idea of like sort of order of magnitude? How does that compare with, say, what's going on with data centers?
I would say that in the next 5 years, the data that we've seen shows that the value of the what we call AI inference, or deploying the technology, and the AI algorithm training and inference that's in the data center, the growth is going to be about 25 to 35% annual growth in the number of billions of dollars. And the growth is bigger at the edge compared to in the data center. And everyone's talking about it, but from what we've seen, more of the growth is in the edge in a lot of different applications that just require the miniaturization and low power and low cost.
And as you're saying, that growth is within business. I mean, those are direct business applications.
That's right. How businesses can save money, businesses can save time, businesses can become more efficient, and provide more accurate and more valuable services to customers through this kind of intelligence at the edge. Because who wants to wait for the data center when you need to know where the customers are coming in, let's say to a store, and being able to track customers and decide how much food you need to be able to make in the kitchen. These are real problems that can save big food chains a lot of money every year.
And as you were saying, it enhances privacy because now we don't have the data leaking back out to other places to be processed.
That's right. I mean, imagine a digital sign that you walk up to and it looks at your demographic, it estimates your age, your gender, and then has some kind of advertisement. I mean, you'd like all of that to be kept locally. You don't really want to you want to kind of have all of that disseminated at the edge and not necessarily bringing that data back through the network. So having privacy is very, very important.
Your background, to me, is defining a new sense of full stack. I mean, you come from a deep bench of doing the technology, building, doing the circuit design, but then going out into the business applications very directly. Can you see, I guess, to give the business use cases a little bit more background, it sounds like some of what you've done with DSP work before fits in these low power applications really directly. Rather than doing a lot of data munging, they're taking data directly, these kinds of chips, right?
Yeah, the interesting thing about the decades ago when I was getting a degree in studying DSP technology, you could prototype on a computer and run applications on a computer, and it didn't have to be as real time. And then slowly and more quickly at an exponential rate, we have the need for real time. Right. For my talk here at O'Reilly, I did some work pulling out computer manuals from the 1960s.
Oh, fantastic.
There was no mention of performance. You had functionality, you had tape drives and this and that. But the need for performance is just so much, I think it's so much more important now because, I mean, the whole idea is that we want to have autonomous devices and autonomous and smart things to enable us to lift ourselves out from having to do very menial manual tasks. Right. If I could have a robot tie my shoes in the morning, I would have that robot. But to build such a robot, you actually need intelligence running in a low-power robot on a battery that can last a long time. Or to even have a smart thermostat in your house controlling the temperature, you have to have a battery that lasts more than a few minutes, and you can't recharge it every night. Right, so it's challenging to be able to do this really sophisticated AI technology, which is now requires even more performance than the kinds of algorithms we were developing in school decades ago. To get the kind of accuracy that we're able to get with those algorithms, but having trillions of operations per second of performance in a couple of watts of power, it takes a lot of work, and that's what we at Intel are trying to do day to day to be able to deliver this technology.
Wonderful. How about making this accessible for developers to get their hands on? Are there kits or SDKs or so?
It's great you asked. Earlier this year, we launched a kit to be able to allow people freely to look at how to deploy their deep neural network, for example. So for an AI, deep neural networks are kind of the rage right now. So being able to deploy it on the CPU and do prototyping of it, and then deploy it on a low-power vision processor. So we have this toolkit called OpenVino, the OpenVino toolkit, which basically was for neural network optimization, which optimizes models for AI. It also has an inference engine that's able to target whichever platform you want to target, your x86 machine, or your CPU, or your VPU, or your FPGA. And so depending on which kind of customer you are, what your business need is, or what your requirements are, you can use the same toolkit in order to deploy on different kinds of platforms. So this toolkit has been great, and it's been people have been getting their hands on it, using it to achieve much greater speed up. Even just using the same CPU before developing AI algorithms, people have just used this new toolkit to get hundreds of times faster performance. So it's really interesting to see the kinds of things people have done with this toolkit that we deployed earlier in the year. And yeah, the sky's the limit in how we're able to deploy the chip technology and then allow people to be able to shift among what technologies they need. Because some companies want to use the cloud, but then they might deploy some devices at the edge. So it's depending on what businesses need. I think there's really exciting technologies that we have to offer.
As a developer, could I be working with, say, I don't know, Python or some sort of open source tooling, developing on my laptop and running on the CPU there, and then use OpenVino just to go directly into
That's right. OpenVino is freely available, and you can use TensorFlow or a bunch of other commonly used frameworks for your deep learning algorithms, and then port them to your CPU on your machine that you're using, and then be able to get some of these low-power platforms. One of the interesting low-power platforms that we deployed last year, and which is doing really well, is this deep learning development kit called the Intel Neural Compute Stick. And the Neural Compute Stick is a USB stick, plugs into your laptop, and then you can have an accelerator running. So we're trying to deploy easier and easier platforms for people to use to be able to get their hands on AI algorithms without having to go get a PhD and have to go, spend thousands of dollars on platforms. We want cheap and inexpensive platforms that people can use to develop AI and then be able to deploy them on Intel.
Fantastic. Thank you very much, Gary.
Thanks. Great to talk to you. Thanks.